Communicating with an ACN drive via Modbus RTU is pretty easy, but there are a few things you need to be aware of. We'll use this click PLC as the Modbus master. The drive defaults to these COM port settings, so we'll just make the PLC match those. To set up the PLC's COM port, we go to Setup, COM port. We'll be using the RS-485 port on the click PLC, so we click on this button. We're using Modbus protocol, and because this PLC is the master, this needs to be a 1. I'll change the baud rate to match the drive's baud rate, and the drive is at 8 data bits, no parity, 1 stop bit. This stuff is fine, so I'll hit OK. Great. The PLC and the drive's COM ports are both using the same settings now. The PLC is wired to the drive like this. The ground wire is important. We'll explain why in Part 2. On the rising edge of C1, let's do a receive. We want to use that port 3 we just set up. Now, if you forgot to set it up, you can do it here too. You would put whatever your drive's address is here. The drive defaults to 1, and since we haven't changed it, this is good. We're going to read multiple registers starting at what Modbus address? Well, we just go to the Serial Communications chapter of the user manual, and we see this chart that gives us an overview of the drive's memory map. Now, we could go to the drive's parameters and read each one individually, but that's a waste of communications bandwidth. Instead, look at this. The ACN drives have this drive monitoring area set aside where all the parameters you would normally want to monitor are gathered together in a read-only block of memory. If I scroll to that section, we see there's tons and tons of read-only parameters all grouped for easy reading via Modbus. We're going to start here at Modbus address offset 784. Where we'll read these 8 consecutive registers. Now, we just need the offset from this 40,000 number because back here in the click software, we see it uses a 400,000 base address, which means we want to start reading at slave address 400,784. Let's put the red values in the memory locations starting at DS101. And we're reading 8 total registers. We could read up to 125 consecutive registers if we wanted to. I'll create some status so we can keep an eye on things. And add the required end instruction. I've already connected to the PLC, so I'll write the program to it. I created a data view with the read trigger bit and the 8 red values. Enable monitoring. The PLC is running, so let's toggle the Modbus read and see what happens. Now the motor's not running, so everything comes back as 0 except the bus voltage. Exactly what we expect. Let's change the frequency to 10 Hz. Enter to select, enter to accept. Now the drive doesn't default to keypad control, so let's go to the drive command source and change it to a 0, which tells the drive to use the keypad for run-stop control. Enter to select, enter to accept, and escape to the top level frequency display. Now if I hit run on the keypad, we see the drive ramps up to speed. And if I toggle the C1 bit, we see our current is 2.1 amps, the output frequency is 10 Hz, etc. Okay, we can read any single parameter or a group of parameters we want from the drive simply by looking up the Modbus address in the user manual. And we also know that all the parameters we might want to monitor are grouped in this convenient parameter monitoring address space, which makes our Modbus communications much more efficient. And I'll press the stop button on the keypad to stop the motor. Okay, instead of using the keypad to control the drive and set the command frequency, let's use Modbus. First, we need to tell the drive to accept commands via comms and not the keypad. Go to the drive command source and set it to a 3 to tell the drive to accept run-stop commands from comms. Now I can't run the drive from the keypad. And let's go to the frequency source and set it to a 6 to tell it to accept frequency commands from comms. Notice that the command frequency isn't 10 Hz anymore. That's because the drive is now using the comms frequency source memory location. We'll write a frequency value to that via Modbus in just a minute. Over in the Click software, let's have the rising edge of C10 send on port 3 a Modbus write. And again, we already set that port up, so we don't need to do it again. We want to write to our drive at slave address 1 a single register. Let's have this guy write the command frequency. In the user manual, we see that's at Modbus address offset 896. So in the Click software, we add that to the 400,000 base, and we put that here. Let's put the command frequency value in register DS110. I'll set up the status for this Modbus write, add an end, and send it to the PLC. I added the frequency write trigger and the frequency value to the data view. Let's change the frequency to something we'll recognize. There's 2 implied decimal points, so that's a 12.34 Hz. The PLC is running, so I'll toggle the Modbus write, and we see it was successfully sent, and the new frequency appears on the display. Perfect. Okay, now let's control the drive from the PLC. On the rising edge of C11, we'll send, on port 3, a Modbus message. Again, we already set up that COM port. And we want to talk to the drive at slave address 1. We'll write a single register to what address? Well, back in the user manual, we see Modbus offset 898 controls the forward and reverse and can be used to reset trips and can also set the drive to free spin to a stop. So we put a 400,898 here, and we'll put the drive control word in location DS200. And I'll add some status and add the required end. I'll send that out to the PLC and update the data view. Okay, the PLC's running, so to tell it to run in the forward direction, it looks like we need to set the first 2 bits, which means we need our drive control word to be a 3. Toggle the drive control write bit. The command was successful, and we see the motor ramp up to speed. Perfect. To stop the motor, I'll change the drive control word to 0 and retoggle that command. And the motor ramps to 0. Well, that should be enough to get you started with reading and writing to the drive via Modbus RTU. But there are some things you need to know before getting too deep into it. So check out part 2, where we'll cover some tips and tricks and fill in a few holes. Meanwhile, click here to learn more about the ACN family of drives. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to our YouTube channel so you'll be notified when we publish more automation tutorial videos.